Hello and welcome back to this old sporadic YouTube video. It's been a little bit of a while since I posted anything, and apologies for that. I've just been swamped with this side project, design project I've been doing, which is about drawing to a close for the third or fourth time, and I think this time finally. So I've had very little time to do anything other than go to my day job and then come back and do more day job. Have done a couple of things. So there was a tiny amount of work on the beam engine, and what I did there, if you recall, there was a raised boss here and a couple of raised bosses there, and I've just removed them entirely because the casting features were not visually concentric to where the machined features needed to be. And I've since learned through some communications with a writer from Model Engineer magazine that that's a common problem. Well, not problem, that's just castings for you. And then the other thing is, with the side project coming to a close, I want to make a thing. And the thing is going to be a tooling plate for rotary tables. This is a leftover aluminium disc from a project at one of my previous employers. And because it wasn't needed, it was destined for the scrap bin. And I intercepted it because at that place we were allowed to buy bits of scrap for scrap value if you talk nicely to the materials manager, who is sadly no longer with us. It's too big for any of the chucks on my lathe. So what I'm going to do is fly cut one surface, turn it over, and then I will drill and tap a few features in it. And then I'll be able to mount it to the faceplate on the lathe and skim it nicely flat and bore a hole in the middle of it. I'm only going to put a few through holes and tapped holes in it at this stage, because the idea is to just drill and tap extra holes in it when needed. I'm not going to do a big grid pattern. Thought about doing that, but I'm not going to do that. I'm going to just put a couple of holes in it and kind of go from there. And in order to hold it on the mill, I'm going to use my nice set of pin jaws that I got from Josh Topper, and these are an excellent fixture, and he has these for sale on his web shop, and I highly recommend you go and buy some. Let's take a closer look at those. Here we are. So you can see it's quite a clever idea, really. They're a set of 4140 pre-hardened steel, and you've got a set of very close fitting holes along the top of each jaw, and you can put dowel pins in there in various positions, as many dowel pins as you want to hold on to awkward shaped parts. So today I'm going to use it to hold this 9-inch disc of aluminium. Nice and snug, and that now gives me space above the moving jaw so that I can drill through in whatever pattern I want. So first thing I'm going to do is give this surface a skim. I do. There is absolutely no, you can't feel a ridge there at all. That's come out so nice. I don't think I need to put it on the lathe. I think I'm just going to turn it over, fly cut it and put the holes in and call it good. Wow, happy with that. Again, there's, you can see the path, which is no surprise, but you can actually see, I don't know if you can see it on camera, but you can see the first pass line and the second pass line, which just goes to show you how well trammed in there is. There is no ridge there at all. I am extremely happy with that. The drills that I'm going to be using don't have a split point, so they don't self-center. So I am marking out the pattern using a center drill first. There's a combination of hole sizes here. 4 of the holes are clearance holes for 3/8 bolts, and the rest are tap drill holes. And this is the spiral point plug tap that I'm going to be using to power tap these holes. Now, this is where the story really starts. I am going to have another try at power tapping threads. Unlike last time, when I used a hand tap, a 4-flute hand tap, I have a 3-flute spiral pointed tap. The better to push the chips ahead of the tap. And I've done more research on this, went back and watched all the videos that I watched previously, and this time have taken note. And so these spiral point taps are the recommended approach. Ideally, I think this would be a keyed chuck, but I've just taken care not to over tighten it. And I've spoken to a number of real machinists and asked them about reversing the machine, and they say it's actually very common practice. Now, there is, of course, I've researched it, and there's a great division in opinion as to whether you should throw your 3-phase motor into sudden reverse, and lots of people say, good God, no, that's the world will end and a black hole will open up and everything will be terrible. Certainly sounds dramatic when you do it. I've done it on this machine just to test it out, and it certainly sounds dramatic. But as somebody pointed out to me, Bridgeports and these mills have been used in that manner for 60 odd and more years, and some of those machines are still in existence, running the same motor they came from the factory with. For it, this one is true of that. and people reverse them all the time without any problem whatsoever. So really the purpose of today's exercise is just to try power tapping again, because I want to, not because I need to. I'm not a production shop. I'm just mucking about in my own home shop, but I like to try things. So let's do it. I'm starting with the one hole that is actually over open space. Mostly. I still won't have a whole lot of time. But let's give it a go. Let's lube her up and try. All I've got to lose is a tap, really. I don't know, that was pretty drama-free. We'll be making more use of that technique. It was very successful. Overdid it with the old snot lube there, but very happy, very smooth. Here I'm just using a boring head to make a straight and true hole in the middle of this fixture plate to use for clocking it in when in use. Well, there you are. It's amazing how well these things go when you just do them properly, isn't it? So that was a little bit of fun, a simple fixture, and I'm glad I did that and got that out of the way. Now it's ready for use. In doing that, it actually revealed some deficiencies in this old Kurt Weiss, and turns out this is neither square nor true in any direction. It's had a hard working life apparently, so I'm going to see if I can recover it. I don't know if I'm going to film that. Anyway, thanks very much for watching. Thanks to all the new subscribers who've joined recently. Thanks to all my long-standing subscribers. Very much appreciate you looking in. If you would be so kind as to do the subscribe thing, that helps the channel get found. I'd really appreciate it, and it costs you nothing. Remember, if you'd like a channel sticker, please just email me at the address above, and I'll gladly send one your way. And if you're unlucky, I'll send you two. In the meantime, be safe and well, and as always, be seeing you all. Stick around for a little tiny piece of work on the beam engine base. It's pretty basic stuff. This is a Bridgeport rotary table, 12-inch, that I acquired last year. I got it from Lost Creek Machine. While I was on my way back from the Indiana Model Engine Show, I picked it up. Anyway, these rotary tables have a plain bore, 1 inch, and so I've turned up a little stub shaft with a 1 inch diameter on it, 0.99999, somewhere around there. And so I'm going to use this as a crude centering technique for this rotary table.